Okay, Assalamualaikum warahmatullahi wabarakatuh. We will continue our subtopic of chapter 4, Bernoulli and energy equation. Previous video I have explained to you the conservation of mass, continuity equation, mechanical energy and efficiency. And now in this chapter we will learn about Bernoulli equation, general energy equation, energy analysis and steady flow. Okay, first we go for Bernoulli equation. Okay, Bernoulli equation. Okay, Bernoulli equation involve of three main energy. Okay, which is three main energy. Which is first is it will involve of pressure energy. Second, it will involve of kinetic energy. Third is potential energy. Okay, so it involves these three main energy: pressure energy, kinetic energy and potential energy. So in this formula, the main formula is P1 plus 1 over 2 rho V2 squared plus rho GH1 equal to P2 plus 1 over 2 rho V2 squared plus rho GH2. So which is, we know that P is a pressure, this is a static pressure. So rho is a density of fluid, G is the acceleration of gravity, V is involved of velocity, and H is elevation of head. Okay, so in details, this equation of P1 plus 1 over 2 rho V2 squared V1 squared plus rho GH1 equal to number 2 is in detail is involved of three main things. For example, for P, pressure. So in this Bernoulli equation, the pressure is a static pressure, so it's not a dynamic pressure. So it's not a dynamic effects, it's a static effects. Second is rho V2 squared over 2, which is our kinetic energy, will be a dynamic pressure. So dynamic pressure is involved of pressure rise when the fluid in motion, there is a movement of fluid. So there is a kinetic energy involved with dynamic pressure. Then the last one, our potential energy, rho Gz or rho Gh, is a hydrostatic pressure. So it involves of elevation effects. So Z or H is the elevation of potential energy effects. For Bernoulli equation, as I've said, it involves of pressure energy, kinetic energy and potential energy. So how it works, for example, we take example of a pipe flow. So we have a pipe flow of orifice pipe flow in between. So we have the area velocity at, this is a 0.1. This is 0.1. So we have 0.2. So here V1 should be A1 here. A1 is area of from here to here. A2, P1 and P2. In this case, Bernoulli effects normally is related with the reduction pressure which occur when the fluid speed increase. Okay, we understand that Bernoulli equations, Bernoulli said that when velocity increase, automatically pressure is decrease. This is Bernoulli equation concept. Okay, so in this case, in order we know that A2 is smaller than A1. So A2, our area of number 2, this is orifice is smaller than A1. So automatically, when area is, we know that V2 also is higher than V1. So because of the area of A2 is small, so automatically the velocity will be moving very fast due to jet flow. So V2 will be higher than V1. So as been mentioned by Bernoulli, when velocity is increased, automatically our pressure is decreased. So pressure at P2 automatically is lower than P1. So this is how this equation relate. Okay, means when the area increase, okay, the area decrease, okay, the area decrease, velocity will be increased because of small area, then the flow will be much faster due to jet flow effects. Automatically, when we know that the high velocity will give you a low pressure, as been mentioned by Bernoulli concept. Okay, so this is the main concept that you need to understand, and you will use it in this topic. Okay. This Bernoulli equation has a limitation. So in order to use this Bernoulli equation, there is a limitation. So it can be used if it's a steady flow. So it cannot be used for transient startup or transient flow, which is during period change in flow of condition. Okay, what is the difference between steady flow and transient flow? Steady flow is flow which is remain the same from T1 to Tn, but transient flow, there is a changes of every time. Means when you take a T1, there is a different flow. When you take a T2, T time at the same area but at different time. For example, you have a pipe here. Okay, you take point number 1 at T1, okay, T until Tn. If the result is same at point 1, means it's a steady. But if T1 have a difference, okay, either bigger or higher at Tn at the same point, so this call is transient. Such as we have a pulsatile flow. Okay, pulsatile flow is something like pumping, okay, or pump. Okay, so for example, there is a graph. So this is your T time, this is your velocity, for example. So if T1, T1, T2, T3 have a changes of velocity, so we call it as a transient flow. But if for example we have another one is it remains the same, T1, T2, T3 is this remain the same, we call it as a steady flow. Okay, second one is friction flow, frictionless flow. The limitation it should be a frictionless flow. So in this case we ignore the friction effects, as we know that most of the every flow should have a friction, but friction effect are negligible, okay, in this Bernoulli equation. So the third one is incompressible flow. The flow should be incompressible, which is if it's air, it should be under the less of 0.3 Mach number. Okay, so there is no compressible effects. Okay, means that incompressible flow means that